So this is part 4 of the sampler Loopstation tutorial or project. We're just going to go straight from soup to nuts all the way through this project. So I thought this time we'd get stuck into processing and start creating the interface a little bit. So, and I'll show you a couple different things that we need to do. So let's first come up with sort of just a basic GUI, couple tracks. Well, the way we'll kind of proceed is we will, with both the audio and the visuals and everything else, we'll do like a one example of one. So for example, we probably would be nice to have a multi-track interface. But right now I'm just going to sort of show you how to do one track. And then it's kind of a different technique. We have to add a couple different tricks and stuff to expand it out to multiple tracks, or make it kind of a flexible thing so we can change a number and change the number of tracks. Demonstrate a few concepts like for loops, and then also the power of variables. You'll see a number of different things. But let's just get started with a basic interface, okay? So as normally we do, and I think the new processing fills all this stuff in for you, but it's no harm in typing a little bit. Void setup, and then we need a void draw. Okay, and in setup, we usually set up the size of the canvas. So let's do something that's like 1,000, and then maybe something like 1,000, and then maybe something that has a 150 height or something. If I'm just doing one track, something like that. Okay. And then if I want to draw kind of a background, I can just use background since I'm just doing one track. But just since I'll be using multiple tracks, I'll have a background of 0, and then I'll draw a track. So in fact, it'll end up taking the whole, the whole canvas, but that's fine. We'll have a no stroke. Okay, we're going to draw a rectangle, but we don't want a stroke. And then we'll have a fill of, and I think I grabbed some kind of bluish fill. I'm just going to cheat here and take a quick look at what I did. Track background. Right. I wonder what that is. Let's try that. 25, 33, 47. And don't forget you have your color selector so you can create your own custom colors. And then we'll draw a rect. And for the time being, it's going to be the size of the canvas. So it'll be at 0, 0 to start, 0x, 0y. And its width will be 1,000. And its height will be 150. Okay. So in fact, it just obliterates this background. But like I said, since we'll have several tracks, we'll do something like this for now. And great. So that's that. If we ran that, we just see a nice track interface, a nice sort of dark blue background. All right. Now let's go ahead also and create kind of a beat grid, because that will be helpful. So this we'll label these. We'll call this our track. And then we'll just draw on top of that track background or draw a beat grid. So right now, I'll just do some manual calculations again. But of course, we will we'll abstract that a little bit so that we can fill, numerous tracks or change the number of tracks quite quickly just by changing a number of tracks number. Let me just see what I do here. I am creating a line and an ellipse. Okay, so so if we make a four measure or 16 beat grid, we're going to have lines at I guess 1,000 divided by 4, right? So have lines every 250. So we'll have lines at 0. So, well, let's just make this white first. Let's have a stroke of white. Okay. And we'll put a stroke weight in, just in case later on we change the stroke weight, we'll make sure that this changes it back. We'll just make them quite thin, okay? And then we'll make lines at 0, right, 0x, and at 0y. And then with, it's a line is point A to point B, so x1 and y1 is 0, 0. x2 will still be 0, but y2 will be the height, or 150. Okay, let's just run that and just see how that line looks. So there's a line there. And so we want to put a line for every measure. If we have 4 measures, then we'll have a line, we'll have a line at 0. We'll have a line at, the 2 x's will then be 250, right, I think? $250, $250. And then 500, 500. And then 750. And that'll be our 4 measures. Right, okay, nice. Okay, and then additionally, I thought it would be handy to have our beats marked as well with some ellipses. So we'll have that beat grid. These are measure markers. We'll indent that. Beat markers. Okay, and let's have no stroke again. And let's have a fill of white. Okay, and we'll make it's centered, so we'll have an ellipse mode of center, which I think is the default, so I won't change that. Though, in case we do change it later on, sometimes it makes sense to do an ellipse mode. That just tells you if it's where 0, so where 0, 0, if I put an ellipse at 0, 0, is that the upper left-hand corner that gets placed at 0, 0 of the ellipse, or is that the center of the ellipse that gets placed at 0, 0? So I will do center. And that will just assure, in case later on in my patch I do change the ellipse mode, it'll just make sure that this one is more centered. Okay, and I'll center these at the same places, except now, so now I'm a bit in trouble. So I can do 16 of these, or I can use a for loop. Okay, so I'm gonna break down now and actually have to rely on the for loop, and I'll show you how to do that. And I might have showed it before, but never hurts to see it again. So for loop is something that goes for. And it starts at a certain point, and it keeps looping until it gets to a certain point. So we define an integer, int I, and oftentimes it is 0, but that's just a starting point. And then we say, go ahead and loop it for a certain amount of time, or until a condition is met. So until, let's say I'm doing 10 of them, so while I is less than 10. So it'll just keep looping until I is greater than 10. Or equal to 10. And we'll have an increment, so I will be plus plus. So that means that I plus plus is the same as I equals I plus 1. Okay, so it just means that the next time it loops by, I gets incremented. It starts at 0, it adds 1 to itself every time it runs a loop. Okay, and of course you can change these parameters as you will. So you can start at a different number, you can increment by a different value. So you can say I, instead of I plus plus, you can say I equals I plus 2. So you can do every other, or plus 2, or I plus 3. And these can be kind of fancy actually. But now we'll use that shorthand I plus 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 1, and we'll go to 10. And I'll just show you real quick, print I. We'll just print I and see what happens. So it's going to loop through, start at 0, print it, go back, loop through, start at 1, print it. Well, look at the condition. Is 1 less than 10? Yep. Go ahead and print 1, increment it. 2, is 2 less than 10? Yep. Print 2, increment it to 3, is 3 less than 10, etc., etc. Okay, so if I run that, you'll notice that it prints me the numbers 0 through 9. Okay, so a for loop is a nice way to sequence, and you can use this I as a variable. All right, so why is that useful here in making these beat markers? Well, I have 16 of these things. And so instead of writing, line, 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 line like I did here, I can write a for loop. I can go for int I equals 0, I is less than, and I have 16 of them to draw, right? 16 beats altogether. I is less than 16 because we start at 0. So it's going to go from 0 to 15. Then I plus plus. Okay. And then, so what am I actually going to do? Well, I want to draw an ellipse, right? But I want to move the x a little bit, right? So I can move the x in relation to I. Okay. So if I have x, so if we divide 1,000 by 16, what is that? 25. Well, I don't know what that is. I should know. 62, 63. So we'll just say 62. So our beats might be slightly off, because it's right in the middle, isn't it? Okay. Well, we'll deal with that anyways. We're kind of fudging it now because we're actually going to kind of change the way we do it when we make multiple tracks. But this is just instructive. So we're gonna move that about 62 pixels every time, right? So we have I times 62. The increment, that means when I is 0, it'll start, the first beat will be at 0. When I is 1, it'll be at 62. When I is 2, it'll be at 124, etc., 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 etc. Okay. So that seems to work out. So that's going to move our x over. Our y is always going to be at the same. So let's put it right in the middle. So we'll keep that at 75. All right. And then that's just the width and height of our ellipse, however we want it. Maybe we'll make them kind of small-ish. Let's see what 8 looks like, 8 and 8. Okay. And so that's going to loop through, and it's going to draw these ellipses for every, until I is, becomes greater than 16. So the way the code runs, the order of operation runs through each line, runs. When it gets to the for loop, it runs the whole loop before it moves on. Okay. So it's going to draw all the ellipses before it moves on to the next thing. So it's going to loop all 16 of them before. All right. So if we run that, and you notice that's easier than writing 16 lines where it says ellipse, 62, 75, 88, ellipse, whatever, 124, 75, 88, and just keep going 16 times. Nice. Like I said, we have some rounding errors, so they're not quite matching up. So you can make a decision one way or the other. I think I deal with it differently when we start actually making variables. So let's just line it up ourselves. So maybe 63 will work a little bit better. Let's see what happens. Okay, not great. Well, we can maybe do 62.5 and just see if that makes an adjustment every time, even though pixels are whole pixels. There's no half pixels, because obviously your screen can't do that. I think it just rounds them mathematically, and maybe it'll just line them up slightly better. And yeah, it does line them up slightly better, which is good. So it sort of pushes one over, it pulls one back, depending on where it is. So let's just keep it there. 62.5, perfect. And it looks nice, a nice little beat grid we got going on. Okay. And I think the final thing for this tutorial we'll do is create that scrolling cursor. Okay. So, and then this will involve a couple of steps. So this will be the most sort of involved part of this tutorial, this one. All right. Let's create maybe a green cursor. So we'll mark that as well. We'll say this is going to be our cursor. Oops. Oh, I didn't end the for. Oh, I did, but I didn't. Okay. So cursor. Okay. And then this again will have stroke weight. And I guess this can be a little thicker if we want it to be, maybe 3. And the stroke will be this lime green that I like. And let's draw a line. And we'll just put it, we'll put it at 0 for now. 0. So x1, x2, y1. So 0, 0. X2 will be still 0, and y2 will be the height, which is 150. There we go. Let's see how that looks. So I have a nice green cursor there. We need to move the x, right? The two x values. They're always going to be the same. So let's make them a variable. We'll say, oops, what did I do? We'll call it cx. Well, what did I call it here? Might as well be consistent. I call them x0. No, cx. I did call it cx. How nice. Okay, so let's call them cx. And that, remember, it's going to be the same always because we want to have a straight line down, up and down. And we'll create a little space here on our root area, and we'll create a variable called, did I keep it a float? Yeah, well, make it a float. That's fine. Because I think it comes in as a float. And we'll set the initial value as 0 for now. Okay. So, you know, it's still there. If we were to change that to, say, 36, it move it over slightly. Okay, so this is the value we want to update. And the way, so the kind of the little innovation with this project, which I like, which I think is going to work well for a lot of different things, is that to drive that using our audio index. So the same index here, this buffer index, that's driving our record and our playback engines, will be the same thing that drives our actual drawn cursor here in processing. So how do we do that? Well, basically that's why we have going out two buses, an audio rate one and a control rate one. Okay, so we're just going to create a little. We're going to create OSCDef that basically is like a pull, what I call a pull machine. So basically, we're going to create a little thing that gives information on demand. We'll create a little OSCDef that says when you call that OSC namespace, when you call that OSC thing, it's gonna send you the information of the index where it is. So basically, we'll have to pull it from processing. We'll have to send a bunch of things every time we draw. We'll send a message saying, "Give me the current location of that index," and it'll grab it and then it'll update CX. Okay, so that's what we're gonna do. So let's start with the super collider area. Okay, so we're going to have to make and I'm just going to make this in these brackets here. I'm going to put a parentheses there and a parentheses there because we can run all that at the same time so that we can just easily run that. These have to be on the outside. And then we'll create an OSCDef. Now, if you remember, def, oh, sorry, it looks like this. It has, its key, which is the name it uses within SuperCollider. And I just want to keep my naming consistent. Get index, okay. Get IDX, we'll call it get. Okay, and then it has a function in these curly brackets that is where all the action happens. And then it has the path, which is actually the OSC name. It's a string, so it has to be in double quotes. It's the OSC address or OSC namespace. And OSC names or addresses always have the backwards or forward slash, I guess you'd call that. And we'll just call it the same thing. Get index. So this is just to use within SuperCollider language. It's its kind of label. All right. And then our thing. And then that's the end of our OSCDef. There's other things we can put in, but we won't. And then we'll just create some space there because that's where all the things going to go into that function there. All right, so what do we need to do? Well, we need to do a couple things. We need to get the value of this index buffer. Okay, bus, I'm sorry. You can just call a get command on that, and it'll give you the value of that. And I believe there's a little bit of a, yes, there's a little bit of a function. Okay, so basically what get does is that you write a little function, and within that function, you can get the value. So let me start up. I think everything's still running. I think it's actually still running. Okay. And so A is this buffer index. It's being written to buffer B, right? Did we just call it B? Oh, IDX bus. Ooh, sound buffer IX buff. So IXB. So that's good. We got to update that. It's actually IXB. So let me recompile and let's start fresh. We'll boot it. We'll send all these things. We can even send the OSCDef just because I don't think it's going to throw an error. No, it doesn't do anything yet. And we'll send this buffer index to go. So it's running a buffer just so I can demonstrate what this Git does. If I do, you're actually getting from the buffer. So the buffer, this control bus is the IXK bus. Okay. So that's where this buffer index is sending this. It's sending the index, this phasor value, which is that thing that's going to keep everything in sync to this bus here, this IXK bus. That's the control. It's also sending the same thing to the audio bus. That's the audio rate one. But that's too much information for processing to handle at a frame rate. It's 44,100 times a second, and the frame rate is about 60 times a second. So we just need a control rate. Even the control rate is pretty fast for it. So just to show you what it does, it's called, right, my buffer is called my bus is called IXK bus, okay? And I can do .get, and if I just evaluate that, it's going to send me the value, the current value. It's at 0.7. If I do it again, it's at 0.9. You know, it's moving to 1 and then back to 0 and repeating, looping, okay? Now, also what you can do, see, it sends a bunch of different information, index and its value. So in order to actually just isolate the value, you can run it as a function. And I believe the first argument then, let me just look at this real quick, is the val, right? Okay, the value. So if I then also encapsulate get, can also run this function here. Okay. Sorry, let me just get, yes, within brackets. Okay, so get, then you run a function within that. So you can have an argument here, val. So this is a lot like, you know, the OSC defs where we have MSG. The first argument that comes in is what's coming into that bus, is the value of the bus, okay? And then argument val, and then that will, then you can run a function, whatever, and then every time you hit the get, it'll run this function. So we'll just do post, we'll post. We'll do the val, and we'll post it, post ln, okay? So basically what we have here is the get runs a function, argument with the argument val being the actual value of the bus, and then it runs whatever the function is val.postLine. So if I run that, oops, did I not do that? Oh, this is on the function, I'm sorry. The entire thing is in the function, okay? So you see now, it just printed out my value 0.121, okay? So now what we want to do in this OSCDef, just hopefully we understood this get bus. So let me just slow that down and just explain it one more time. We've created a synth-def that indexes this phasor. It's reading a number from 0 to 1 at an audio rate, so it's very accurate, and we can use it as a play head or record head to move it. And then we're sending that index information out to both an audio bus and a control bus. Now remember, these are a lot like patch bays, like an actual cable, but it's just virtual. And they have private buses, so it doesn't have to actually go out to one of your speakers. So control data and audio data, we've created these two buses, an audio one and a control one. Now, we're just concerned with the control bus data right now. So this buffer, once we started this index synth, it's sending information out to that bus we created, this control bus we created, and the audio bus, but we'll just talk about the control bus. And we're going to use this get command to get the value of that current value of that control bus. So that's why this is IXK bus. That's the control bus we created. Okay, it's going to get that value. So we want to, though, get that value on demand. So we're going to send a message from processing to SuperCollider with this address, get index, And when it gets that message, it's going to pull the bus to get the value, and it's going to send a message back to the sender. It's going to send a message back to processing to say, this is the value you requested. Okay, so it's an on-demand service, which is nice, so that we can actually do it at the exact rate of our frame here, our frame drawing rate. It can just demand it every time it wants to draw. It can demand a new value. So that'll be a little bit smoother rather than this just flood of information coming to processing and it having to use it. So let's set that up. And I believe I just do a processing send message that oh, right, IX and a val, right. Okay, so we have to send it to things. So first thing we have to do is we have to set up a processing address. So we can set up a net address. I think I'm calling this variable PROC. Okay, let's do it up there with all our other variables. So this is going to be a net address. That means a sending destination. It's quite easy to set up in Super Collider. You can just go net ADDR, and it's looking for the host name. Well, I'm just using the local host or sending to myself within the same thing. You probably will be too, which is 127.0.0.1. And then the port, and that's whatever you defined in processing. I'm using 12321, okay, which we haven't done yet, but we'll set that up. But you can be whatever port you want it to be. All right, and then so when we want to send that message, we're going to say processing. We're going to send a message, we're going to say proc.send msg, okay? And then it's whatever message we want to send, it goes in there, okay? So basically what we're going to do is we're going to get this get thing, and instead of the value being posted, we can still post it if we want, we're going to send the message to processing. We're going to do proc.send msg, okay? And now the first thing has to be our the first argument has to be our OSC address. Now we haven't set up the processing side, but I'm just going to create one called IX. So that means that it's the receiver on the other end is going to be looking for this message IX, okay? And what do I want to send? I want to send that message val, okay, right? Because that's the value of the bus. So I'm going to send under this heading IX, I'm going to send the message val, all right? And we've got to just make sure, because processing is a bit finicky about data type, so we just want to make sure it's a float as float. Okay, we'll just guarantee that by doing it that way. Okay, so it's pretty simple. We're going to get this and send it. So every time we get, so I'm going to copy that in there, paste that in there. Let's see. Let me just fix it things up. Basically, every time we get this get index message, it's gonna pull the bus, and the function that runs every time it pulls a bus, every time it gets a value in, is basically to send back a message to processing under this address. Processing send this OSC message back, and it's gonna send with it this value as a float. Okay, so we got to do two things in processing now. We have to get one that sends the request to this get IDX, and one that will receive this IX with the value. Okay, so we got to set up two things in processing now. All right, I hope that makes sense. I hope that wasn't too fast. Right. Anyways, yeah, hopefully you get that. You can just review it if you don't. Okay, and we can get rid of this. We don't need that right now. Okay, so we have that OSCDef set up. I won't evaluate it just yet. Well, let me evaluate to see if I made any mistakes. Yeah, no, it seems to be fine. I just make sure that's exactly okay. Well, this is a little bit different just because that's a setup for multiple buses. Yep, that looks pretty good. Get IDX. Okay, now to the processing side. So the processing side, maybe this should have been a separate tutorial, but that's okay. We have to set up OSC. Okay, so we've done this probably a couple times. Hopefully you have done it a couple times. The first thing we have to do to get OSC going is we have to import it's an external library. So IMPORT, and it's OSC P5.star Okay, and then net P5. Another way to do it, well, you have to import two different libraries, so it's called net P5 dot star. Not sure if that's a capital O and N. Well, we'll find out. So that's one way to do it. Okay. Another way is to go to Tools and or Sketch and import library, and then go to OSC P5, and it'll just add that text there. Okay. That's probably a little bit easier, but it's good to know how to do it in case that service isn't working, or just so you know. So we import the two libraries. We have to create some variables. One will be our OSC machine. So its data type is OSC P5, or its class. And I was just going to call mine OSC. So that's the actual OSC machine. It needs to be a thing. It needs to be an object running in our patch. Okay. And I'll initialize it in the setup. So I'm just defining that right now. And then we have to have a destination. So we'll have a net address. Okay. And you notice it's similar in language to the SuperCollider, because it's pretty much the same thing. It's just more complicated to set up and processing, but we have a destination, a sender. So it's a net address, and we're going to call this SC for SuperCollider. Okay, and let's set those up in setup. So what we have to do is say OSC, that's the variable we created, which is the OSC P5. We have to initialize it. So it equals a new OSC P5 data type, and then sometimes each of those initializations, the class, takes some arguments. In this case, it's the using context, or the part of our sketch or our code that will be using this machine, OSC machine, and this is the root. It's everything. Okay, and then also it is our port number, I think, 12321. So I'm going to set that up to be 12321. Now I think I have to do some fancy schmancy things later on, but we'll get into that later. Yes, I do. But for now, that's good enough. Yeah, so that sets up, that's your basic setup anyways. Most of the time you'll do it this way. And then we have to set up our OSC address. So SC equals a new object or new class, a net address. And this requires its IP address, in quotes. So it's 127, sending to myself.0.0.1. And the port, so the hard-coded or the default port for SC lang, or the language side of the SuperCollider, is 57120. So we'll send it to that port. Okay, so that's all set up. So we have the machinery now to be able to send and receive OSC messages in our processing sketch. Now what we were saying is that what we need to do to get that cursor to move is every time we update, every time we want to update the CX, right? So we're going to send a message here to pull what that value is, and when we receive it, it's going to update the CX, okay? So we're going to send an OSC message to SuperCollider, and if you remember how to do that, you go OSC MESSAGE. We'll just create a variable OSC message. We'll call it MSG. We'll call it IXMSG. How about that? Okay, and we'll equal to a new OSC message, and its address. Then it's OSC address, which will be whatever we call it. What do we call it? Get IDX. Okay, so get IDX. Okay, will be its name. Okay, so now we have a message called IXMSG that is going to send a message under this OSC namespace get IDX. Okay, and then we'll add something to it. So we'll say, oh, we don't actually have to add anything to it, because it's just gonna, just getting that message will prompt it to send us back the index. So all it's looking for, it's not sending any arguments at all with it. Okay, so that's easy enough. So that's what's going to happen, but we have to send it. So we have to say OSC, that's our machinery, that's our OSC machinery.send. Okay, and what is it going to send? It's going to send the IX message, MSG. And who's it going to send it to? It's going to send it to SC, that net address that we set up. Okay, so the message plus the net address at its destination, this net address. Okay, so there you go. So every time, now this is running at the frame rate, so every time draw runs 60 times a second, it's going to send this message. And as soon as this receives the message, it's going to shoot it right back. This processing.send message is going to shoot right back under IX. Okay, so now we have to create a receiver. Now, as I mentioned before, and I've gone over this in previous tutorials, if this is the first one, then hopefully this will be enough to get you by. Otherwise, you can look back at some of the other stuff. So we're going to create, we're going to use a service called OSC Plug, which is like a forwarding service built into the OSC library, the OSC P5 library. I find this the easiest way to deal with receiving and sending messages. There are some cases when we won't be able to do this in this project, but not in this particular case, more to do with the bigger data. All right, so what we're going to do is we're going to set up a function, okay, and the forwarding service plug basically lets you receive a something under a certain OSC address, and it'll just forward it to a function. Okay, so the way you write functions in processing is you write it in the context it's active. So in this case, root. So that means this function will be available everywhere in my patch. Okay, so you notice I did it outside of draw. It's just in the blank space here after or before. Doesn't really matter actually even where I put it, because when processing runs, when it compiles, it'll go through and pick up all my functions, and then it'll create a sort of dictionary of functions to be used. And void is usually something start. So one way of looking at like setup and draws are kind of like functions in a certain sense. They're probably more like methods or classes, but we won't worry about all that. So, and I can call it whatever I want. I'm going to call it, well, let's be consistent. What did I call it here? Oh, it uses all this public void business too. So that might be good, but rec on, pause, play, TRIX. Okay. Right, okay. So I call it track IX because it's per track. So we'll just keep that, TRIX. Okay, that's the function, tricks. Okay, and then we create some arguments, which we'll fill in later. And so these are the arguments coming in for our message, which is really just one. Well, I don't know why I have the two. Okay, well, there's a track number. We don't have different tracks, so we'll update that one later. So we have a float coming in, and that float is the, it's the actual location of our cursor. So we'll put it, IXX, maybe something like that. I think I call it something else. Oh, IDX. So IDX, okay. Now, when it comes in, then basically we want to just update the CX, okay? But we got to do a couple things, though, because we have to update that CX, but we also have to map it. Remember, it's a number coming in from 0 to 1. That's what our index is doing. That's the most useful for our play head and record head, because it's running through a normalized number 0 to 1, right? And then we just map everything out. So that's why those normalized numbers are handy, because you can map that out quite easily. So what we'll do is we'll take the index and we'll map it out. We'll create a variable here. We'll call it float, and we'll call it IX map, something like that. And we'll say it equals to map. We'll use the map function. And what's going to be mapped? It's the IDX. It's the number coming in this function, okay? And where is it going to be mapped from? It's going to be mapped from 0.0 to 1.0, right? Because it's coming in as a number between 0 and 1. And what is it going to be mapped to? Well, the entire length of our canvas. So from 0 to, we made it 1,000, okay? So that's going to give us an accurate thing. So in fact, we don't even need to put this variable here. We can just say CX. CX, right? Because that's the variable we want to update to move our line. Okay, so every time we get in, it's going to forward this to this function. Every time we get a message in, it's going to forward to this tricks function, and it's going to look to see that we have a float attached to that as an index, and it's going to send this index in and update this mapped value, update CX. Okay. Now we just need the forwarding service, so we need to go up to setup, and we have to do, we're going to use again our OSC machine, OSC, And we're going to use this function called .plug. Okay. And basically, this is just going to forward anything on. So it needs operating context again. So THIS, this. And that just becomes relevant later on when you start making your own classes and stuff like that. Sometimes you want to plug into an individual class instead of everywhere. Okay. And but you'll cross that bridge when you get to it. OSC Plug. And then the first thing I believe is the function that you're going to forward it to, the name of the function, and you just put that in quotes. So we said TRIX. So it's going to forward this information. Once it gets a message, it's going to forward it to our TRIX function, and just as long as that exists. And then the third argument is going to be the address that it's looking for. So IX, right? So if you recall, we are sending, every time it receives get index, it's going to send back this message, IX, okay, along with that value as a float, okay? So then we're going to, so then this plug forwarding service, every time it receives IX, it's going to forward all its data. And so you notice we don't have to actually specify which data, just as long as that we match it up. It's going to forward all the data that comes with this IX to this function TRIX. So TRIX is looking for a float index, and it's just going to update CX. Okay, so hopefully that all works, but let's do a couple things here to show that things are working. Okay, for example, every time we get index, we will post something. So we'll just post, we'll just do hello. We'll post something. Okay, so just make sure that that direction is working. So I can just do this OSCDef. I don't have to do everything here. And I think it might do everything though, but that's fine. It'll move the cursor and everything, but I just want to, we'll just do one step at a time. So the idea is that every time it draws 16 times a second, when it gets to here, it's going to send this message to SuperCollider get index, and then it'll post into our window here. Hello. Okay, so let's run that. And okay, and you notice, oh, okay, it says send message not understood because I didn't evaluate processing, but that's okay. It's still, let's stop the machine there. It's still printing that hello somewhere, right? It is printing hello. So at least that direction's working. Okay. And then just to show, well, it'll move the cursor. The thing I didn't do is evaluate that. I didn't have a net address for it to send to. Okay. And we'll just show that this is working. It's sending a message, and we'll show that it's being forwarded here by printing line here. And we'll call it, we'll do a goodbye. Okay. So it'll be hello here and goodbye there. Oops. Oh, because I stopped that. Okay, so hello there, goodbye there. Okay, good. So those are working. And if you see, it's actually, it should be moving, but it's not. Oh, because we don't have any of the machinery on. Okay, so hello, the goodbye there. So we know that two-way communication is working. So we know that this is sending this message every frame. It's getting into here, and it's posting hello. It's sending back a message IX, which is then going through our plug, forward to Trix. Trix is getting it here and printing this goodbye. Okay, now let's just, I just wanted to show you that. That was probably unnecessary, but show you all that working. And now we'll get everything, all the machinery working, because there's nothing to send because the get index that wasn't running. The synth wasn't running, right? So there's no value there. So I recompiled, I booted my server. I'm going to send all these, including my OSCDef. It'll all go together. I'm going to start my index synth because we need that running. Otherwise, there won't be any data coming through. Okay, so now that's running. I don't need to start these record and plays yet, just because, yeah, I'm just trying to demonstrate that. And then I'll run my processing patch. Okay. And so it's moving my cursor very nicely. and in sync with all my audio objects, because it's that same index that's generating the motion for everything, for the index as well as for the record and the playheads. Okay, so that's what's coming. So every time, every frame, I'm requesting from SuperCollider a new location, and it's sending back the location, and then the function is updating my CX value, which is the line X, the two X's of the line. Okay, so that's how we get that motion there. You can generate this type of animation from within processing. However, by polling the index from SuperCollider, everything's very tightly synced up together. So your cursor is at the same time your playhead and record heads all synced together by one source, which is this one index. Okay, this one phaser object, which I find nice and tidy. It works really, really well. Okay, so that was a lot of information. Hopefully, it didn't go too fast, and hopefully that was understandable enough. I think next time, what will we tackle? We'll probably start tackling maybe some waveform displays or something like that. Well, I'll decide for the next time. Okay, well, good luck with that, and hopefully that's clear enough for you to understand.